Unit 1, Lesson 1 is about rational numbers. When you first start learning about numbers, we use natural numbers, which are the counting numbers, like you would use to count objects, 1, 2, 3 blocks, and so on. The next step is to recognize the value 0, or having absolutely nothing. The list of the natural numbers, including 0, is called the whole numbers. Eventually, you're going to reach a situation where you need to have numbers that value less than 0. For example, with temperature, the positive numbers are going to be above freezing in Celsius, and then the negative numbers would be temperatures below freezing in degrees Celsius. This list of all of the positive whole numbers, including negative whole numbers, is called integers. Numbers that represent only parts of a whole can be written as fractions, decimals, or percents. Altogether, these numbers are called the rational numbers. Remember, this includes whole numbers, integers, which includes the negative whole numbers, and then also fractions, decimals, and percents, which represent parts of a whole. Not every number is rational, like pi or the square root of 2. Only numbers that can be expressed as a ratio of two integers are called rational numbers. We're going to see some examples of how to convert rational numbers between the different forms of fraction, decimal, and percent. We'll start by taking the fraction 5/8 and converting it into a decimal. 5/8 means 5 divided by 8. We can use long division to convert this from a fraction into a decimal. We have to ask how many times 8 goes into 5 evenly. Since it does not, we convert this to a decimal and add an extra 0 on our number. Now we would see how many times 8 goes into 50. 8 goes into 50 6 times with 2 remaining. We would add another 0 and continue this process. 8 goes into 20 2 times with 4 remaining. And 8 goes into 40 5 times with nothing remaining. Once there is nothing or 0 remaining, we have converted our fraction into a decimal form. This means that the fraction 5/8 is equal to the decimal 0.625. Now let's convert a mixed number, -1 and 2/3. Remember that this means we have 1 whole plus 2/3. What we want to first do is convert our whole into 3 pieces to show that there are actually 5/3 total pieces. So -1 and 2/3 also could be thought of as -5/3. We can now use long division and see how many times 3 goes into -5. Whenever we're going to divide with a negative, that means that our answer will also be negative. And we simply ask how many times 3 goes into 5. 3 goes into 5 once with 2 remaining, so we create our decimal and add a 0 to continue. 3 goes into 20 6 times with 2 remaining. When we add a 0, we get the exact same number as before, and 3 is going to go into 20 6 times. This process is going to continue to repeat over and over again, which means we're going to continue getting 6s over and over again. This is called a repeating decimal, where the same digit or digits repeat forever and ever. This means that -1 and 2/3 is equal to the repeating decimal, -1.66666 going on forever, or we can also write that as -1.6 with a line over the 6. That line is called bar notation and is used to indicate that the 6 is a repeating digit. Now let's look at how to change a percent into a fraction and then a decimal. 45% literally means 45 out of 100, since percents are parts of 100. We can simplify this fraction by breaking down 45 and 100 into its prime factors. 45 is the same thing as 9 times 5, and 9 is the same thing as 3 times 3. 100 is the same thing as 10 times 10, and 10 is the same thing as 5 times 2. Once we've broken down both the numerator, 45, and the denominator, 100, into its prime factors, we can cancel out any factors that are the same on top and bottom, and multiply the remaining factors back together to see our simplified fraction. 3 times 3 is 9, and 5 times 2 times 2 is 20. Now remember that 9 over 20 means 9 divided by 20. We can use long division, as used before, to get the decimal form of 9/20ths, which is 0.45. If you know the original percent, there is a shortcut to get to the decimal, which is to simply take the decimal point in the percent and move it 2 spaces to the left. This means that the percent, 45%, is equal to the fraction 9 over 20 and also to the decimal 0.45. Now let's look at how to change decimals into fractions. If we have the decimal 0.45, we're going to use the place value to determine what it would be out of when we write our fraction. Since the decimal 0.45 terminates or ends in the 100ths place, that means that it is 45 out of 100, or 45 hundredths. We can then simplify this fraction using the method before of factoring and canceling out factors that are the same on top and bottom to see that the decimal 0.45 is equal to the fraction 9 over 20. Repeating decimals have a slightly different process. Remember that the bar over this 5, or line over the 5, is used to indicate that that 5 is a repeating digit. We're going to use the tool called a variable, where a letter represents a number, to change this repeating decimal into a fraction. We're going to use the letter n to represent our number 0.55555. We're also going to use the place value, where our repeating digit is, and multiply our number by 10, since our repeating digit is in the 10ths place. Now, with a variable, when I multiply my number by 10, that means I have 10 of my number, or 10n. On the right side, when I multiply 0.55555 by a 10, I simply move the decimal one place to the right and have 5.55555 repeating. Next, I'm going to subtract my original number. On the left, with the variable, if I have 10 of my number and I subtract it, I will have 9 of that number remaining. In other words, 10 n's minus an n is 9 n's. On the right, we're going to subtract starting on the far right side. Since 5 minus 5 is 0, all of the digits to the right side of the decimal are going to be repeating zeros, and 5 minus 0 is 5. The repeating zeros after the decimal do not change the value, so that's the same thing as just 5. Now we're going to divide our number by 9 to see that the original number is 5 over 9. This means that the repeating decimal, 0.55555 repeating, is equal to the fraction 5 over 9. We use a similar process when we have more than one repeating digit. If there is a line over 1 and 8 on our decimal, it means that both the 1 and the 8 are repeating digits in the same order. We're going to use a variable to represent our number. In this case, we'll use r to represent the number 2.181818 repeating. Since our repeating digits are in the 100th place, we are going to multiply our number by 100. 100 times r is just 100 r's. 100 times 2.181818 can be found by simply moving the decimal 2 places to the right. We end up with 218.18181818 repeating. Now we are going to subtract our original number. 100 r's minus an r is 99 r's. On the right, we're going to start on the far right side and subtract. An 8 minus an 8 is 0, and a 1 minus a 1 is 0. So all of those repeating digits to the right of the decimal are going to turn into zeros. And then 218 minus 2 is 216 before the decimal. Those repeating zeros after the decimal do not change the value, so that just equals 216. Now we're going to divide by 99 to show that our original number is equal to 216 over 99, which can be factored and simplified to equal 24 over 11. This means that the repeating decimal 2.18 repeating is equal to 24 elevenths, or 2 2/11.